In this video, I would like to look briefly at what logicians call logical operators. An operator is simply a functional symbol. It tells us how to relate with and engage and compare various clauses within an argument. Now, as a quick caveat, these symbols are not universal. They are not global. If you look at various programming languages or even different subsections within logic itself, you will come across various different altercations to these symbols, although their function is very much the same. There might be a couple important differences depending on the specific context you look at. However, what is most important here is understanding what the symbols do. Another way to look at a logical operator is they are an analog to traffic signals. Whenever you approach an intersection, you need to know how to behave in context to that intersection. A green light means to behave in one particular way, so does a yellow light or a red light. And these operators function very much in a similar way. So in order for an operator to have significant meaning, it needs to have context. So let's give ourselves a little bit of context here. So our A portion of the argument will be apples are fruit. The B portion will be apples taste good. Now let's look at some of the most common logical operators. The first is and. That's represented by this asterisk here. Most of the time in introductory logic courses, this will actually be a filled in circle, although this was the closest symbol my keyboard possessed, and this means both. Both of these have to be true at the same time for this combined clause to be sound. So in this particular case, apples are good and apples taste good. Both of those must be true for this section to be sound. And another way to look at this is mathematically, where A plus B, those both are entirely combined together. They work in conjunction with one another. If one of these are determined to be false, this entire clause is then rendered false, and that particular section is then unsound. The next operator is OR. Here we have the symbol represented in this V. This is a pretty close representation of it. It's normally a little smaller, although the point is here's a better way to look at it. At least one of these has to be true in order for this combined clause to be sound. Either apples are fruit or apples taste good. One of these has to be true for this clause to be sound. Now, both of these could still, let me say it this way, both of these could be true, and that would not contradict this particular operator, because remember, at least one of these must be true. So if both are true, then it's still a sound clause. Next operator, if then. So this tells us that if A is true, then B is also true. It's represented by this mathematical symbol here. There is a more distinct type of symbol that's normally associated with if then, although this was the closest one I had available. And so all this is saying is that if apples are fruit, then apples taste good. Now note, by looking at the actual logical flow of this argument, we may have some disagreement here. However, this is what this particular argument is demanding. So if A is true, then B is also true. That requires primarily that A be true. So even if B is true, but A is not, then this particular clause is rendered unsound. So B is predicated on the soundness of A. The last one, although not least, and of course there are many more operators, although I chose this as a brief survey, is not. That is indicated by this symbol here, and all it means is that the truth, or not the truth value, excuse me, the content of the clause that it is representing, that it is not true. So for example, if we looked at A and we applied the not to it, the argument then becomes apples are not fruit. Or if we applied it to B, apples do not taste good. And therefore, it simply changes it reverses, or perhaps inverses, that may be a better way to look at it. It simply inverses what the standard meaning of the particular clause that it is associating with.